that by providing various numbers of tools, right, and various numbers of processes. So we have studied about relational databases and how relational data is stored uh, in the last session, right? Data fundamentals with understanding the relational part of it. In today's session, I'll be dealing with the non-relational part. Okay, the data, the Azure systems that are provided to deal with non-relational data. Okay, and we will also see some analytics that can be done on this data, and what are other components of analyzing a data, right? That is something we'll see in today's set of slides. Okay, so I'll share my screen. Okay, so I hope the screen is visible.
Yes, sir.
Okay, just give me a minute, it is being loaded. All right, so can you see the slides on explore fundamentals of non-relational data in Azure?
Yes, sir. Yes, sir.
Okay, fine. All right, so we will be exploring these fundamentals, but first of all, we need to know why exactly do we need this data, right? So we are capable of connecting to internet and gather data from various places, right? The sources of data can be unlimited. Okay, we will look at some sources later, but when we retrieve this data, when we store this data, it doesn't have to be relational, right? It will not be structured at every point of time. Okay, that is one case. Other case would be if I'm setting up an organization that takes or that deals with some few values of data and probably deals with images. Okay, for example, the receipt I give, okay, for the business whatever I'm running, and I take the image of that receipt. So most of the time I'm dealing with a data that is not structured. Okay, so in that case, I would not at all need something as something which is similar to relational database, right? So the two scenarios that we see here, that why do we need non-relational data or not fundamentals to deal with non-relational data, is first thing, the data may not be available in structured form always, or I may not need structured data at all, right? So once we are aware that the data that I'm dealing with will not be structured, or structuring it, normalizing it would be a difficult task, I can have, or I can come up with things that will deal with this non-relational data, right? The data that is not that structured. Okay, so that gives us the objective to learn the non-relational databases and how we deal with it with the help of Azure. Okay, so we will in this set of slides we will study about Azure storage. Okay, what are the different data storage? Okay, how do we store data, and various forms in which this data can be dealt with. Okay, and one of the most specific databases that deals with or that caters to this type of data, that is unstructured data or non-relational data, is Azure Cosmos DB. Right. So we'll go into Azure Cosmos DB in brief. Okay. So in fundamentals of Azure storage, what are we going to learn, or what are we going to see? The first thing is we'll try to understand or explore what an Azure Blob is, or Azure Blob storage is. Okay. So basically, an Azure Blob storage is something is definitely a part is a definitely a non-structural data. That is why we are studying it here. Right. Next, we will deal with Azure Data Lake Gen 2. Now, what is this data lake? What is this Gen 2? We'll go into it. Okay. Then we will go with file storage. File storage meaning the probability or the possibility of sharing files online. All right. And then we'll have one more structure, data structure, that is table. Okay. Now, is this the same table that we deal with in relational databases, or if it is different, then how different it is? That is something we'll go and see. So the very first thing that we'll study is Azure Blob Storage. So the blob storage is something, a blob is something that stores massive amount of unstructured data, right? And how does it store it? It stores it in the form of binary, okay, binary objects. That is why we call it binary large objects. Okay, so these are very efficient way of storing large data or large unstructured data. Now, what can be a large unstructured data? It can be a pixel form of an image, right? The pixels can be converted into binary digits, and then we can have a large string of bytes and bits running. That can be considered as a blob, right? So this can be a very efficient way of storing unstructured data. Now, before going into the types of blobs, you can see that there are three types of blobs we are seeing here. But before going to the types of blobs, I also want to take care of how these blobs are stored. Okay. So the first thing, if you see in the figure on right, you see that there is something called as Azure storage account. Okay. So the very first thing that we do is to create an Azure storage account. All right, and then to categorize these blobs into some similar characteristics, right? So if let's say if I have 100 blobs that are needed to be stored, there has to be some similar characteristics, thus forming some groups, right? So each group of blobs can be stored as a container, right? So that can be one way of distributing these blobs, right? So within the Azure storage account, I have blob container. Okay, and then I store the blobs in the form of some directory structure. Okay, now if you see this, there is one blob, that is blob one, that is stored directly into the blob container, and the other one is stored as folder one slash blob. Okay, now what do we understand from this? Do we have, in general sense, if I see something like blob container folder one forward slash blob, blob two, what I'll try to understand, or what do I interpret from that? That there is a some folder structure, some directory called as blob container. Within that, there is a folder called folder one, and then there is blob two. Okay, so there is a hierarchical structure. That is something that I interpret. Okay, but that is not the case with blob storage. Okay, this folder one forward slash blob two is just a way to categorize all the blobs that have similar characteristics in the form of folder one. Okay, so these are called as virtual folders. These are not the actual folders, but virtual folders, just separated by a forward slash, just to say that this particular blob belongs to this folder or this category. Okay, now if these folders are virtual folders, I cannot manage these folders, meaning I cannot have operations, I cannot perform operations on them, I cannot give access control to those folders. All right, I cannot do a simple task of at least as minimum as renaming the folder. That also cannot be done. Okay, so that is something we need to take care of. In the Azure storage account, blobs are stored in the form of virtual folders and then the actual files. Okay, now that we understand how blobs are stored, let us talk about different types of blobs. Okay, so blobs have three different types. One of that is block blobs. All right, so block blobs are large discrete chunks of blocks that are connected together forming a blob. Okay, so we can see that each block here can span up to 100 MBs, and you can have 50,000 such blocks in connected together. Okay, this together, like each block of 100 MB connected together with the number of 50,000 such blocks create a blob. Okay, and then you can see how large it would be. It can go up to 4.7 TB per blob, right? So that is something we need to understand. Okay, the other would be page blobs. Okay, here we this page blobs are stored in the form of fixed size pages. Okay, what is the size? 512 bytes. Okay, so these blobs are stored into fixed size, and you can see how many numbers of pages can be stored, because the blob can span up to as high as 8 TB, right? So this is the part of page blobs. Now, where do I use page blobs? Page blobs can be used to assign virtual disk, right? For example, if I am working with a virtual machine, each virtual machine is given certain memory at the backend, okay, at the server side. Okay, now how that memory is assigned? That memory is assigned can be assigned that can be assigned with the help of page blobs. Okay. Next is append blob. So what is append blob? Append blob is nothing but a smaller version of blobs with an additional functionality of you being able to append a different block to that blob, right? So let's say I have a blob of 100 GBs. Okay, I can add a smaller chunk of block to it. Let's say 2 to 3 MB and make it a part of that blob. This facility of blobs or blob getting added to a blob is called as append blobs. Okay, so these are the three different blobs that we look at. Now, when we store data, we also want to know what is the latency and what is the cost of data, right? I mean, the storage cost. Okay, so based on that, we have divided the storage of these blobs into storage tiers. Okay, so there are things like hot tier, cold tier, and archive tier. Now, what does hot tier mean? Hot tier has the highest cost and lowest latency. So the high cost is because of the lowest latency. Latency is how frequently or how fast you can retrieve the data from the cloud or wherever it is stored, right? So if the latency is lowest, we can see that this blob or this piece of data must be getting used very frequently. Okay, that is the reason we call it hot storage tier. Okay, so the storage tier which is very frequently in use, which is mostly live. Okay, a second part to that would be a cold storage, okay, or cold tier, which has a slightly higher latency than the hot tier, but it costs low. Okay, if I have a data that I don't want to retrieve very frequently, and I can manage it being retrieved, or I can spare that certain time to it for it to retrieve, I don't need to pay extra cost for getting it frequently. Okay, that is the reason we have something called as hot cold tier. Okay, a blob can be shifted from tier to tier. It can go from hot tier to cold tier. For example, if I want to retrieve a data very frequently now, I can shift it from cold tier to hot tier. Okay, then there is a data. In generally we refer to it as a historical data, where we want it to be saved, where we want it to be secured somewhere, but we won't be using it very frequently. Okay, it will be used once in a year, something like that. Okay, so in that case, I don't want to pay an additional cost of it being available readily to me, right? So I can bear the time that it takes for to come to me, right? That is the reason we have something called as archive tier. Okay, now in the hot tier, a data can be retrieved in the blink of an eye, probably in milliseconds. In cold tier, it will take some seconds to some minutes. Okay, but in archive blob or in archive tier, it will have it can take hours. And why is that? In archive tier, generally we know that we are not using this data. So what we try to do is we save this data into in the system that is locally stored somewhere. Okay, we don't have this data available on the cloud. Okay, we store this data locally. Now this data, when I want to retrieve it, what will happen? This data from archive tier goes to first cold tier and then to hot tier. Now this conversion of data from archive tier to cold tier is actually called as rehydration. Okay, what I'm trying to do, I'm trying to rehydrate the data, that is making it being available for me to use, right? So that this rehydration process takes the actual time. Okay, that is the reason the latency is highest for archive tier. All right, so this is about the blob storage. Remember what we didn't have in blob storage, the hierarchical structure of data, right? I mean, I could just create virtual folders which do not actually have any meaning, but the idea of not being able to manipulate this folder, not being able to have some control on this folder is okay, something that this part lacks, right? Blob storage. Now, how do we deal with that? To do that, what we need to do is we need to upgrade our file storage account or Azure storage account. So if you see on the right, the figure on the right, you still have the same Azure storage account, but the same blob container, but instead of now folder 1 and blob 2, we have a directory. Okay, so converting a data or shifting my data from a blob storage to data lake gen is called as is something that I want because it gives the hierarchical namespace to the data, right? Here I can create a data such that it has a hierarchical directory structure wherein each directory can be managed by me. I have the control for that. Okay, I can give the access. I can probably rename it. Okay, I can have the control of moving it from one place to another. Right, so that control is there, and that is the same that we have in our normal systems, right? So we create folders and files into that. So we have the control on what we want to do with that folder. Okay, so that is done, or that functionality is given by Azure Data Lake Gen 2. Now, what is this Gen 2? We have this Gen 2 because we have a Gen 1. So this Gen 1 was a, was a different service from Azure. Okay, it was a part of Microsoft, but it is a different service for Azure, which deals with hierarchical structure of data. Now, to be able to, bring that facility of data lake into Azure storage account and store our blob with it, therefore we give it a name Gen 2. Okay, so this is something that we do with data lake storage Gen 2. Now the problem is, there is one small problem here. If I want to convert my data storage account from blob storage to data lake Gen 2, I will have to upgrade my account. That is something that we would do. Okay, but if any point in time I decide that I want to go back to the original data blob storage, right, that is not possible. I mean, once the storage account is updated, it is updated, right? That is why we call it one-way upgrade process. I cannot degrade it back to blob storage. Okay, so that is something we have to keep in mind. The third thing would be Azure Files. Okay, now what is the general trend in which an organization handle files, right? So conventionally, what would one do? An organization would have a central system where all the data relevant to that organization are stored, right? So that data then will be shared to its employees and taken care of, right, and managed. Now what happens is, when you have a number of employees within that organization, it is easy to manage because there is a handful, or there is that number is manageable. Okay, generally these connections are made by LAN. Okay, because the employee of that organization come to that place and use the data. Okay, the problems arise when the number of employees increase, that is the sharing members of the data increase, and you want to spread out, the organization wants to spread out its branches to other places of the country. Okay, in that case, managing a local area network becomes difficult. All right, so what is the alternative? The alternative would be to have a centralized system, but instead of it being a local system in the organization somewhere, have it stored in the cloud, right? You store it on the cloud, form a network of connection, and then you add people. Okay, these are the employees that I want to share my data with. All right, so that is something is done with the help of Azure Files. Okay, so same thing, we start with an Azure storage account, we create Azure file share. Now this is done with the help of a container where all the shareable files are added. Okay, now once this container is created, you create the network. So you see this gray dotted lines, right? This is nothing but the network. Okay, and this is the container where I keep my shared files. Okay, and this is the person who is actually making the use of this data. All right, so what is this network? So this networks are nothing but server message block and network file system. So actually these are two different protocols in which the network is established. Okay, now if you see, this requires premium tier. What does this mean? All right, so if I am taking a place on server on cloud where I want to store data, I have an option of, actually, how do I want to store the data? Now, what is actually a cloud? Cloud is some machine, some remote machine, a physical machine where our data is stored, and we create that connection so that we can use that data, right? So that server, being a physical machine, have its hardware. That hardware can be either HDD, the normal hard disk that we see, or it can be a solid state device, right? SSD. Okay, if I am using HDD for storing my data on the cloud, it is called as standard tier. Okay, and if I want to use SDD to store my files, where the retrieval time would be very good, right? The read and write time of the files will be very good. I use premium tier. Okay, so that is something. Now about the protocols, the server message block is a standard protocol that we use, and that is mostly used by all the common operating systems like Linux, Windows, and Mac OS. Okay, but the network file system are confined to some Linux machines and Mac OS machines, and as it is mentioned, they use premium tier. That is, they use SSD to store their data. All right. This also serves uh, uh, this also serves things like redundancy and encryption, right? Redundancy meaning you create multiple file share options where, if the loss of one data from one place will not cause you any harm, right? Now, talking about certain statistics, this Azure file shares allows 10 TB of data to be stored. Okay, one storage account can store 10 TB of data. Okay, with the smaller constraint that the file that are stored in that data, or the file that is stored in the account, cannot extend 1 TB. I mean, I cannot have a file that is 1 TB in size, okay, or more than that. It can be less, any number of files, but the total content should not be more than 10 TB. I mean, I can definitely extend it with some subscriptions, but that is what we get. Okay, and then at this point there can be 2000 shareable accounts. Okay, meaning I create a storage and I can share this storage with 2000 heads, right? That is something which Azure Files provide. Now, talking about the next part, that is Azure Table Storage. Table storage, I mean, if I look at table, the very first thing that comes into my mind is the relational table, right? With some data schema. Okay, but that is not the case here. Okay, the Azure storage table are different from the relational tables. Why are they different? Because they store data in key value storage, right? They store the data in the form of key value. Now, what is this key value? Okay, the key is nothing but a combination of two different keys, which is called as partition key and row key. Okay, why is this necessary, or why are we having this partition key and row key? Just for it is a kind of indexing. Okay, I can have similar type of data or similar type of records with a partition, and then each record within that partition can be represented by a row key. Okay, so you can see that row key meaning a key of a row, right? So it represents a row. Along with that, I have a timestamp. It is a good practice to have a timestamp, and these tables generally do that. Okay, now what is so different in this table and the relational database table? The very difference is denormalization. Okay, the relational table are normalized, meaning if I have to follow a rigid schema, I have to follow a rigid structure of the table. That is not the case in this table. Okay, if I look at any relational database, I will never see different number of columns for a table. Okay, for multiple instances of that table. Okay, for example, if I want to store a person's information, and then the person has two addresses. Okay, in a conventional relational table, what would I do? I will create two instances of the same person with two different addresses, right? One below the other. So in that case, it will have different primary key, and each record will have its own existence. But in the table of non relational database, in the table storage, what can we do? We can extend this row to have two different columns for address. Okay, and there can be a record or an instance which has only one address. So meaning we can have variable length of rows, or we can have columns that have variable, or we can have rows that have variable number of columns, which is definitely not the case in SQL tables, right? The relational tables. So that is how it is different from conventional or relational DB. Okay, now how do we uniquely identify a record? That uniquely identification is done by a combination of partition key and row key, right? So the key value storage, if you see here, the key not only represents the single key, it represents a combination of partition key and row key, right? And every record in this table would be a unique record with the unique combination of partition key and row key. So if you see here, you will never see another 1 and 123. Okay, there can be 123 repeated, there can be 1 repeated, but the combination 1 and 123 will not be repeated. Okay, that is something we see in Azure table storage. Okay, so these are the things that I've discussed here: blob storage, data lake gen 2, file storage with file sharing, and table storage. These are the various places where I talk about non-relational data storage, right? We will do a short exercise on this also, probably at the end of session, but I want you to take a knowledge check at this point, right? And after this, we'll talk about some personalized queries. Okay. So the first question is, what are the elements of an Azure table storage key? Right. So I just mentioned, right? You can, yeah. So I can see the things coming here. Right. So I mean, many of you got the idea, right? The Azure table storage key is a component key that has two component, that is partition key and row key. Table name and column name, yeah, I mean, it does not make sense, right? Row number again does not make sense. So partition key and row key would be the right answer. Next is, what should you do to an existing Azure account in order to support data lake for Azure Synapse Analytics? Okay, forget about Azure Synapse Analytics at this point. But what we are trying to do, we have Azure Storage account and we are trying to make it data lake Gen 2, right? So what we do, the very first thing is we upgrade it, right? So as to have a hierarchical namespace, right? So the answer would be C. Which Azure option should you use to create cloud-based network file shares? File shares, Azure Files. Okay, I can see mixed replies. Why? Okay, so the first answer to first one is partition key, row key. Second one is to upgrade it, and third one is to have Azure Files, because Azure Files is the way of sharing files online. Okay, I will stop sharing for a moment and go to chats. Okay, so while I am going to chat, just to see if there are any queries, if you can unmute yourself, if you have queries, you can ask. Okay, there is one question: why VM memory uses page blobs and not block blobs? Okay, one question. All right, so this is the only question. Okay, so basically this is, I mean, it's not that there is certain reason for it. It is how Azure does it. Okay, Azure provides the virtual machines. If you are creating an Azure, it gives the page blobs to it. Okay, one reason for that would be, if I'm talking about virtual machine, I'll deal with files. Okay, and when I'm storing files, when I'm working with files, every file can represent a page. Okay, that block in block blobs, it can be a 100 MB long, right? A 100 MB long block of bits. Do I really need that? I don't think so, right? But when I'm dealing with page blobs, I can have a file structure stored in the form of pages and store it as a VM memory, right? So it is probably the memory that VM provides, it is giving you more flexibility with page blobs. Okay, that can be one of the reasons. Okay, but the thing is, it Azure does that, is what I mentioned. Okay, whether Azure Table uses Azure Files or Azure Blob for storing data, it stores in key value pair, right? So it's not using files or something. It is individual data structure which stores key and value. Okay, and every value can be represented as an attribute of that table or column of that table. Okay, so Azure File is a different data storage technique. Azure Blob is a different data storage technique, and Azure Table is one different. That is why we are dealing with them differently. Okay. So if that is okay, I'll move to the next part of this slide, next part of this presentation. All right. So we'll talk about fundamentals of Azure Cosmos DB. Okay. And what is this Cosmos DB and why do we use it is something we'll see in this small piece of slides. Okay. So what we generally do, we'll describe features and capabilities of Azure Cosmos DB and identify APIs that support or that Azure Cosmos DB support. Okay. Now, why are we talking about APIs at this point? I'll let you know. Just give me a minute. All right. So what is this Azure Cosmos DB? Azure Cosmos DB is a database solution from Azure that helps you to work with non-relational data, unstructured data, NoSQL data, right? Can it only do that? No. I mean, Azure Cosmos DB can be used to analyze relational data also, right? But it is what we can say, it is uh, utilized, or it is stabilized in the form so that we can use NoSQL databases better with Azure Cosmos DB. Okay, so that is what we are trying to do. Now, if you see here the figure on right, we will see that the Azure Cosmos DB and the data that it supports. Okay, one is the document database. We have a JSON key and then value. Okay, other is key value table. Okay, the key value that we see, it is, all these are forms of non-relational database, right? I mean, these type of database are covered in probably last session, but okay, doesn't matter because we'll be again seeing them. Okay, the third would be column family stores. Okay, now what is this column family? Okay, we'll see. And then there are graph stores. Okay, graph storage. So these are all forms of databases where I can store unstructured data, right? And therefore we have Azure Cosmos DB, you know, maximize in its functionality for storing unrelational data. Okay, I mean, it is optimized for that, but can it not be used for a relational database? No, right? It can be used. Definitely, it can be used. See that with the help of APIs. But what are the cases where we actually should use Azure Cosmos DB? Okay, all the cases where we are in probability of getting unstructured non-relational data. Okay, so what are the examples? Let us talk about IoT and telematics. Okay, Internet of Things. So what is this IoT and telematics? It is basically retrieving data from a particular device. Okay, for example, if I'm talking about a traffic signal, the traffic signal is giving me data and I'm not sure what type of data it is, whether it is structured or not. Okay, that can be a perfect example where I can use Cosmos DB. Okay, another would be the another would be another IoT device which gives you burst of data, right? Data coming in large chunks of bytes and bits. Okay, so in that case, whether performing, I mean, analyzing that data and then storing it would be better, or whether to have a way where I can directly analyze and store that data, right? And that case I can use Azure Cosmos DB. Okay, another way, another probable place where I can use this thing is retail and marketing. Okay, so if I talk about Microsoft, the Xbox that Microsoft has, the Microsoft Store, right? These are all retail stores where I can, download app and have their information. Okay, these are like e-marketing. So all this information can be directly stored in Azure Cosmos DB, right? In fact, the Xbox and Microsoft Store are using Azure Cosmos DB for their storage purposes. All right. Another thing would be gaming, right? So for example, we all know the game PUBG, right? So we have this game where number of people are connected in real time. Everything is happening so fast that, I mean, we do not have, I mean, the conventional database do not have even time to, process that. Okay, this is the data where I have, this is the place where I have large chunks of data. I have to connect with the social networking of these, participants of the game, right? There can be leaderboards, right? The leaderboards of the games. So all these places are places where the data comes in and data changes very fast, okay, in real time. So to have this real time changing and processing, we can have things like, we can use Cosmos DB. Okay. Another example of using Cosmos DB would be web applications. Okay, so I create a web application or mobile application using certain frameworks. Okay, one of the frameworks is Xamarin. Okay, so you can all use those frameworks and store the data using Cosmos DB. Okay, so these are all the use cases where you can actually use Cosmos DB. All right, now I talked about certain APIs. Now what do these API do? API, so basically the structure in which Cosmos DB is designed and worked with is same. right? Now this database being able to connect to different forms of data, whether it is relational, whether it is non-relational, whether it is unstructured data, it has to connect with the help of APIs only. Okay, and some of those we'll see here. Okay, so the first one would be the Azure Cosmos DB for NoSQL. This is where we actually want to use Cosmos DB, but we'll also see some other use cases. Okay, so for Azure Cosmos DB for NoSQL, how do I connect with Cosmos DB? I connect with simple SQL queries. Okay, so the Cosmos DB is optimized to work as a relational database even for NoSQL data. Okay, the only thing is it returns data not in the form of tables, it returns data in the form of JSON. Okay, so I do a conventional query to Cosmos DB, okay, and then have the data in return in the form of JSON. Okay, another would be using Cosmos DB for MongoDB. Okay, now MongoDB, how do I connect with MongoDB using Cosmos DB APIs? Okay, so the API provide me something called as MQL. Okay, MongoDB query language. Okay, now this query language is not like the standard or conventional SQL queries. Okay, we are not doing select and something. Here we are doing more of a class and object access. Okay, if you see here db.products.find, it is a more object oriented way of accessing a data, right? So you see that db class products method, products again attribute, and find is the method, right? So you do that and you get data in the form of JSON again. So MongoDB returns data in the form of JSON because it is a example of document database, right? So here ID 1, 2, 3 act as a key and you get the data in the form of JSON, right? So this MQL, MongoDB query language, is probably the one that triggers the API so that you have the data with MongoDB. Okay. Another would be PostgreSQL, right? It is conventional relational. So as I said, I mean, although it is optimized for using no unstructured data, there is no stopping us from using it with for relational databases. Okay, how do we make sure query to relational databases with our query statements, and how do we get the data in the form of tables, right? So that is what we are getting in PostgreSQL. Okay, for table data, the one that we have just studied right now. Okay, so you can see the information that we are getting, right? It is having partition key, row key, and then the attribute. Okay, so key value storage API, I mean, you just have to put in the query and then you get the answer. Okay, what do you get as an answer? A table database. Okay, then we have something called as Apache Cassandra. Okay, so Apache Cassandra is also compatible with Cosmos DB. Okay, and then the last one is Apache Gremlin, which is an example of graph database. Okay, so here again an unstructured data or unstructured database storage, making use of Cosmos DB. And I mean, there is a very complicated way of writing the query. We write v dot vertices dot something like that. I mean, I'm not sure with the query, but this uses this Apache Gremlin. It is a graph database that also uses Azure Cosmos DB. Okay, so this is how we make use of Azure Cosmos DB in various types of databases and various types of dealings of databases, right? Okay, so I mean, we again have a lab for this, but I would suggest you to do this lab by yourself, because doing this lab is actually exploring these APIs. Okay, and probably we will go with the NoSQL database and table database. Okay, so the lab there it is. It gives you the idea of NoSQL database. I mean, how to connect with NoSQL database using Cosmos DB and with the table database. Okay, that is something you'll see in this exercise. Let us have a quick knowledge check again, right? So which Cosmos DB API should you store and query JSON documents in Azure Cosmos DB? Now JSON is which of the following? Okay. So JSON is an unstructured data, right? It is a NoSQL data. Next question. Which Azure Cosmos DB API should you use to work with data in which entities and their relationship to one another are represented in graph using vertices and edges, right? So just now we saw that Apache Gremlin is a graph database, right? How can you enable globally distributed users to work with their own local replica of Cosmos DB database? Okay, create an Azure Cosmos DB account in each region, very highly unlikely. Use the table API to copy data to Azure stable storage. Enable multi-region writes and add the regions where you have the users, right? Most probable answer. Okay, so for JSON, since it is a NoSQL relationship type, NoSQL database type, we'll use Cosmos DB for NoSQL. Graph, Apache Gremlin, and then you have to enable multi-region. Okay, so that's all about the first section of today's slides, right? I'll again stop sharing just to see if there are some doubts. Okay, so this is where we saw how Azure helps us, or Azure has this relations for non-SQL data. Okay. Okay, I'll try to take doubts if there are any now. Somebody speaking?
Sir, am I audible, sir?
Your
Hello.
voice is quite breaking. Is it Lakshya speaking?
No, sir,
I'm really sorry, man. I'm not
Am I
able to hear you.
am I audible, sir?
Yeah, yeah. Now you are a bit audible. Yeah, go ahead. Hello.
So my doubt is related to generation of. So is the Gen 1 and Gen 2 is a different two services, or is the updation of Gen 2 is the updation of Gen 1?
I mean, see, it's not like updation. It's like initially what the Gen 1 was a standalone platform. Okay, it was own Azure different service. It was not related to Azure, the service that we are seeing here. Okay, it was by itself a different service. Okay, now we are using that service, Gen Data Lake Gen 1. We are using that service and storing non-relational data in the form of blobs. Okay, since we are doing that and having it used it differently, I mean, not like the one. I mean, the Gen 1 was used to store all sorts of data, right? The file storage. Data lake, I'll discuss later what data lake does. But here, what we are trying to do, we are using the capability of Gen 1, okay, of being able to have an hierarchical structure while storing data and storing blobs. Okay, so that ability of Gen 1 with the additional capability of storing blobs is making it a different version called Gen 2.
Oh,
Okay.
okay, sir. Okay, sir. Got it.
Yeah, so I mean, there is some lag or probably issue with voice, but I hope you got the idea.
Hello.
Yeah.
Yeah, last day, sir, I was trying to do this lab assignment. So when I was trying to validate this Gen 2 data lake Gen 2, I was not able to validate. So what must have been the reason? Like there in lab assignment, there is an option when you are upgrading it that we have to
Okay,
upgrade.
so did you uncheck the soft storage, soft delete? Did you uncheck while creating a storage account?
Yes, I did. Like according to like whatever the
Uh,
instructions were given on the side screen, it was given. Like rest of the thing I was able to do, but only at that point I wasn't able to do. So I just
okay, I mean,
No,
can you try
sorry,
back because one of
you are right. No, sir, you are right actually, sir. We had to uncheck that soft delete, sir, multiple places actually, not only one place.
Mhm.
And this thing is not mentioned in the lab, sir. This thing is not mentioned in the lab. When you see the error message, right? So you might be seeing enable some 7 days storage for multiple things, right? Blob also and the storage account
Yeah,
also,
yeah.
right? So
Error
that
log.
thing you have to, yes, I also got the error. So when I went through the error, I mean, you have to disable that thing. Okay, no storage must be there. I mean, because you're deleting account, right? So it doesn't, it actually, completely against the policy of storing the data for 7 days, that thing, right? So you have to disable that property for Blob also, storage account also, that level. Just see where the places you have this thing, uncheck that thing, then you perform the action. And this thing is not mentioned in that lab actually. This is something you have to learn it while doing the lab.
Okay, you can try that once. So I mean, basically you have to uncheck all the fields.
Okay, we'll see it again.
Yeah, you can try it once. Maybe we'll go through that lab here, and then we'll see if there is any if we see the same issue. Okay.
Actually, I do got the same issue, sir. Then I unchecked and it worked for me.
Okay. Yeah. Yeah. So there is in Python we have Boto3 package for all AWS work. So do we have any package for Azure also? Probably you will have. I'm not sure. I mean, I do not have idea of that. Definitely, because see, if you are using some package to connect with AWS, there has to be some other package in Python where you connect with Azure. So probably there will be, but I'm not sure which one. Okay, so I'll move ahead with the next module. Give me- All right, can you see the slides?
No, sir.
So, okay, you
Not
cannot.
yet.
Okay, wait. Okay, can you all see now?
Yes, sir.
No, no, sir.
Okay, no, it is being
Yeah,
shared.
yeah.
Probably it will take.
It's visible, sir.
Okay, fine. So in this module, we'll deal with fundamentals of data analytics, right? So what is basically data analytics and why actually we are doing all these things? Basically to analyze data. We store data from various forms in various databases connecting various APIs, but basically what do we want? We want analysis of data, right? So that is what we'll try to see in upcoming slides. So what are we trying to see in data analytics? First, we'll see the large scale data warehousing. Okay, we will see what is data warehousing first, and then we'll move on to next step of large scale data warehousing. Okay, then we'll see streaming in real time analytics. Okay, probably the most possible way or most probable way of getting bulk of data, streaming data, right? And then we'll have data visualization. All right. So with large scale data warehousing, what are we trying to learn? We're trying to identify what are the large scale data warehousing solution. Okay. What are the key features of data ingestion pipelines? I mean, how data is ingested and what are the stages? Okay. And then related stores that or services that Azure provide. Okay. So basically, this is what a large scale data warehousing architecture look like. Okay. But before going to this part, I want to give a brief of what is data warehousing. Okay. So data warehousing is nothing but having the transactional data stored in the form of relational database. Okay. Data warehousing is having a transactional data. You retrieve the data from all sorts, perform normalization on that, make it transactional, and then store it in the form of relational database. That is data warehousing. Okay, why do we want to do this? To have analytics with business intelligence. Okay, BI. Okay, so we want to have this relational database so that we can have all sorts of analytics or visual representation of this data. This is called as data warehousing. What is it? To store the data in the form of relational databases. Okay, we'll go into details of that structure, but this is what we need to know with data warehousing. Okay, now why do we call this large scale? Okay, when the data becomes big data, right? So you may have heard this term about big data. I mean, having a large chunk of data analyzed. And here, when I talk about large chunk of data, I'm no longer talking about SQL database or relational database anymore. I have to take care of every data. It can be a relational database, or it can be a data in the form of files. It can be data taken real time. It can be data taken in terms of batch. Okay, so if you see the very first column here, you have a drum which represents SQL, right? Relational database, and then you have a file. Okay, so now when I talk about large scale, I'm not really confining myself to relational database. It is also there, but along with that, I can have data from other sources also. Okay, this data, loading this data, extracting it, restructuring it, and making it available so that you can either visualize it or make models to give business insights is something we call it large scale data warehousing. Okay, so large scale data warehousing has two components: conventional data warehousing, which I just said what it is, and having this capability, having services that are capable of doing the same processing on large data, or so we call it as big data, right? So combining these two things, we have large scale data warehousing. Okay, so what are the different stages? The very first stage is to be able to process and take the data, right? That is data ingestion and processing. What actually happens in data ingestion and processing? We extract the data, either we load it first, then transform it, or we transform it and load it, right? So you have these two processes called ETL and ELT, right? So this is done. Then data is
Hello.
distributed. Yeah, somebody speaking.
फ्री हो क्या?
Hello.
तो यार वो कह रहा तुम्हारे अकाउंट में 1,000 रुपए है, अकाउंट में होना चाहिए.
Okay, some person talks. Anyway, so we have this data stored. Okay, then once this data is loaded, we can have all sorts of processing. Okay, what is actually processing? Uh, Filtering this data. Okay, filtering meaning we have our own funnels, right? We can filter data according to the way we want. Okay, and to be able to do that is called data processing. Okay, we can batch store this data or use this data in real time. Okay, for example, if I have large chunk of data coming from let's say uh, real-time streaming, let's say I'm having a CCTV camera, so it is a real-time stream, right? A real-time data. So I can have a large chunk of data coming from, let's say, years coming from that CCTV. What I can do is either I can process it, compare it with the original values or the previous values that I have, okay, or store them in the in the form of batches. Let's say January month, February month. So these can be called as batches. Okay, so this is something that I can do. Okay, this is called as taking the data and processing it. Now what to be done with that processed data is the next step. Okay, so we create analytical data store. Okay, so analytical data store comprises of two things. Okay, one thing is data warehouse and second thing is data lake. Okay, so I already mentioned what data warehousing is or data warehouses. Okay, so data warehouse is having or being able to store data in the form of relational database. Okay, to be able to store data in the form of relational database is called as data warehouse. Okay, and to store, now since I don't know where the data is coming from, whether it is coming from a relational database or it is coming from file, I should also have a provision to deal with this data if I have a file, right? So for that I have file storage, right? And whenever I want to work with data that is not a relational, I'll store that data in the form of data lake. Okay, relational data warehouse, non-relational data lake. That's all. Okay, and then there can be hybrid structures, right? Hybrid structures where some of the data can be stored in the form of data warehouse, or some of the data can be stored, some of the data can be relational, some of the data can be in the form of file or blobs, right? Such place are called as data lake houses, right? Or lake databases, right? So these are the hybrid stores for analytical data. Okay, now what do I do with this data? I'm doing a lot of processing, a lot of storing, lot of batch processing. What do I need to do? There are two things that can be done. One is to directly use this data to visualize something. I mean, just want to see the trend, how it is going. Okay. Another thing is to create insights, to create business insights. Okay. How should I modify my certain things so as to get a particular result? That is done with the help of analytical data modeling. Okay. So you see this cube. This cube represents model. Okay. And why do we go with that particular structure of cube? We'll see. Okay. So let us talk about creating analytical data model with the help of data that is stored in the data store. Okay. So what is this model? This model, I mean, in general, what does a model do? Okay. It has some sets of data that is coming from that was there from the previous way, right? I mean, I had previous storages from where I took the data. I saw that, okay, this is the input, this is the output, this is the input, this is the output. I kind of create a relationship or a transfer function between input and output. Okay, if these are the certain types of input, what can be the output? This is called, and the thing that predicts that output is called as model. Okay, how do I create that model? I put in certain parameters that actually affect my result. Okay, now each parameter can be called as each dimension of the model, and that is why we have cube. Okay, so you can consider cube as a three-dimensional space or a Cartesian plane where you have three axes, right? X, Y, Z. Each axis represent each dimension, and each dimension is nothing but the actual parameter that is affecting the result. Okay. Now, combination of these parameter, combination of values of these parameter give you a result that is called as measure. Okay, and that is why we call this V as a cube. I mean, there can be multiple dimensions, right? There cannot be only three parameters always. There can be multiple parameters. There can be things done with two parameters also, right? But the best way of just representing it is done with the help of cube. Okay. Now that I have measures, I have complete idea of what should my model give when this particular input is, or these are the particular parameters. What I do, I will have better understanding and better insights for visualization, right? I will have better understanding for visualization. I'm really sorry if there is a background noise. There is for some construction going on there. I'm okay. Just bear with me for a minute. All right. So this analytical data model, I hope you got the idea. What it is doing, it is creating insights. It is creating a model wherein I can find output for any type of input now. Okay. I had certain values, I processed them, I got a model. Now I can put any values as a input parameters and check what the output can be. This is a better way of analyzing or visualization of data, right? Because now I have future trends also, right? So basically, these are the four steps that happen in data processing, data warehousing. Okay, data, raw data taken, ingested, processed, stored in analytical data store, used to create data model, and then finally visualized. Okay, let us talk about. Let me see if I can change. Yeah, let us talk about ingestion process in detail. Okay, now ingestion process is not a very simple process. Just receive the data and make it available. Right? Ingestion process has these three things, right? Extract, transform, load, or extract, load, and transform. How is this actually done? This is done, all these process require data, right? I want to extract, I will extract data. If I want to load, I will definitely load data. If I want to transform, what should I transform? Data. All these three processes are related to data. And all the process that are related to data can be called as or can be put into a pipeline. Okay, so basically what a pipeline is all the sequential processes that you would want to do on a particular parameter. That parameter in our case is data. Okay, so you want to do certain things to extract it, certain things to load it, certain things to restructure it, transform it. All things are happening on data, so we create a pipeline. First you do this, then you do this, then you do that. Just basically defining steps on what should happen with the data, right? So this is basically creating pipeline. Now, how do we relate this process with the services provided by Azure? Okay, so there is things like Azure Data Factory and Azure Synapse Analytics, which allows us to create this pipeline. Okay. While creating this pipeline, what do they take into consideration? They take into consideration the input data set, the actual process that you want to do, that is called as pipeline, and the output data set. Okay. Now this input data set can be taken from storage account. Do you see the icon? Do you remember the icon? It is the storage account icon. Okay. Also, we are naming it as linked services. Why linked services? Because storage account, multiple things are linked to that. Okay. If I'm creating a VM, if I'm creating a Blob account, if I'm creating a relational database server, relational SQL server, all these are linked services that can be done in a single storage account, right? And that can be a primary source of data. Okay, so I have input data set from the link services. Okay, I can define certain SQL. If the data is relational, I can define certain SQL processes. Do you understand an SQL object called stored process? Right, you may have seen that in the last session. A stored process is predefined functions in SQL that you want to do on the data. Okay, it's not like simple querying and getting the result, querying and getting the result. Querying, applying logic, getting functionally done something, and getting the output is called stored procedure, because you are storing that procedure within the query, right? So SQL can be used to do the stored procedure. Okay, if the data is relational, so that can be one of the pipeline thing. Okay, second thing is to process the data in real time. Process the data meaning to have a distributed system where you can extract the data, load it from one place to another, have it copied. Okay, filtering can be done based on certain logic. Okay, all things can be done with the help of these two things, these two icons there. These represent Azure Databricks and Azure SD Insight. Okay, I mean, you can read about it in detail quite. Okay, so these are the distributed processes that actually perform data processing or extracting data, transforming data into the way we want. Okay, then I can have some custom logic. I mean, there is only so much this Databricks and HD Insight can do, right? So if I want to do certain things, for example, if I want to filter it based on filter a data of customer based on the region of customer, right? I can create a function which will help me to filter this out. Okay, that can be done with the help of Azure Functions. The icon that you see here, this one, this is Azure Functions. Okay, and if you see this icon and this icon, right, these are both Azure Synapse Analytics. Now, why do we have Azure Synapse Analytics to create a pipeline, and why do we have Azure Synapse Analytics as a data output set also? Why do we have that? One thing is, as I said, Azure Synapse Analytics is a service provided by Azure to create pipeline, right? Now this output data can be an input data to some other pipeline, right? It can be. This output data can be, I mean, it can be directly analyzed, no issues, but it can be an input data to some other pipeline. Therefore, we will output this data or store it, send this data back to Synapse Analytics. Okay. Although these both are Synapse Analytics, this Synapse Analytics define this pipeline, and this one may define another pipeline. Okay. So that is how data ingestion and processing is done. I hope that is clear. I'll take the questions once we end this model. Okay, now talking about data stores. As I said, I'll talk about them in a bit detail. So this is where we see them. Okay, so data warehouse, large scale relational database stored and query engine, right? So it is, we are saying that it is denormalized for query optimization. Maybe, I mean, normalization is done so that we can have rigid schema. Okay, but we are talking about schema here. So let us talk about what the structure is. So if you see here these four things, right? The solar panel things. So these solar panels are nothing but the tables. Okay, I mean, I'm talking about this. Okay, so these tables, you see that there are four tables outside and there is one single table here. So these four tables outside are called as entity tables. Okay, entity tables meaning all the tables that somewhere contribute to my business, the things or the data that I store from my business. For example, if I talk about products, I talk about product ID, orders, okay, and then customers, all those things. Okay, so I keep information of customers, I keep the information of products, I keep the information of categories of the product, I keep the information of orders, of customer and order, customer making an order to get a product, right? So that also can be taken care of. So these, let us consider all these tables take care of these different entities, customer and all. What is this center table? This center table is called as fact table. Okay. Now fact table meaning it will have only numerical values which will represent one of the keys from these tables. Okay. I mean, in a customer table, I can have things like customer name, customer city, address. All those are names and strings and stuff. In orders, I can have order ID. Order ID can be a string. Okay. In products, I can have product name, which can be a string. But in fact table, I'll have all the numerical values because they actually represent the primary keys of other tables. Okay. Now, if I try to read one of the records of fact table, I can see something like this: product ID, customer ID, order ID. Okay. Since these can be primary keys to other table, the answer would be, I mean, one of the possible rows would be 111, right? Order ID 1, product ID 1, customer ID 1. That will be an input or that will be a record of fact table. Now, why do we call it as a fact table? Okay, because I can directly remove a result from that fact table. If you remember this 111, what does this mean? The product with product ID 1 was taken by customer with customer ID 1 having order ID 1, right? So I can completely interpret this single row from the fact table. That is why we call it as a fact table. That is a fact. This is a fact. Okay, that customer with order ID 1 had taken this product with product ID 1 and proof of that was order ID 1, right? So that is why a fact table will always have numerical values. Okay, and if you see, if I try to add one more table here, fact table will again remain in center, but if you see, this will act as a solar system, right? And every table will give you a shape of star, right? That is why we call it as star schema. I mean, you see the star schema, right? So it looks like a star with four hands. But if you add one more table, it will become more intuitive because we understand star with 5 hands, right? Just a representation. So we can have multiple tables, multiple entity tables that are connected with a fact table. Okay, let's say if I want to add a table called countries. Okay, and that country ID is 1. So if all are 1, what can I interpret with a fact table? Customer with order ID 1 has taken this product with product ID 1 in country with country ID 1 having order ID 1, right? So all this one will give me an actual complete sentence which will give me a complete information of what was the transaction actually. Okay, and therefore we call it as fact table. And if you see the topology, we see that it looks like a star and hence we call it as star schema. Okay, now if I try to move ahead with products, I can have product category which is a sub table of product table, right? I can have in customer, I can have customer region. Okay, I can have customer age group. I can have gender. All these things now will have an hierarchy of tables. Okay, you have a core tables, but then there are hierarchy branches branching out. Okay, and then when you see this table, it will look like a snowflake, like a cell of snow, right? That is why we call that a snowflake schema. Okay, when we have more hierarchical structure on this uh, on this table, right? And all these are relationally connected. That is the reason we are telling them we call them as data warehouse. Okay, then we have data lake. So what do we store in data lakes? Data lakes, we generally store data files, blobs. Okay, in the form of file structure. If you see here, the tables there are stored as files. Okay, and then we also see that the services that are provided by Azure, like Azure Synapse Analytics, Databricks, HD Insight. Okay, all these are there to actually process the data, right? So I hope you understood the difference between you understood what are different data stores and why we call this as data warehouse and this as data lake. Okay, and move forward. These are the services, right? I mentioned about these things when we talked about the pipeline, right? So basically Azure Synapse Analytics is a complete framework which gives you everything, because as I said, it was there to create pipeline. So starting from ingestion of data all the way till providing processing, all the way till giving output as a different data form, we can use Azure Synapse Analytics, right? Azure Database and Azure SD Insights are very specific. So if you see this, Azure Databricks are used for Again, it is used for processing, as I said, but HD Insight is more of used for open source frameworks. So if you have this Hadoop, Spark, Kafka, Storm, HBase, these are all open source frameworks that work on processing of data. And SD Insight just uses these frameworks from outside. Okay, now when SD Insight is using some framework from outside, there can be certain limitations. Okay, so therefore we say that SD Insight comes up with a limitation. Okay, so these are the services. I mean, we can go through each of them in detail, but and you can actually study them in the form of lab exercises. Okay, yeah, so the lab exercise is quite extensive for this module. Okay, we'll have a quick knowledge check. Which Azure service can you use to create a pipeline, right? So we just saw that Azure, what can be used to create pipeline? Azure Database and Azure Cosmos DB, that will be to store, right? Synapse Analytics and Factory, right? Because we saw Synapse Analytics and Azure Data Factory that were used to create the pipeline. What must you define to implement a pipeline that reads data from Azure Blob storage? Okay, a link service for Azure Blob storage account, dedicated SQL pool with Azure Analytics, Synapse Analytics Workspace, and Azure SD Insight cluster in your subscription. I mean, what is the answer? We're getting B. Okay. Which open source distributed processing engine does Azure Synapse Analytics include? Right. So Azure Synapse Analytics include Spark. Okay. Hadoop can be used by Azure SD Insight. Okay. Let's see the answers. All right. So we have Azure Synapse Analytics and Data Factory. Azure link service to Azure Blob storage account, right? I mean, if I go back multiple slides, I can see that what was the actual input to the data pipeline, right? It was Azure storage account, right? We also call it as link service, and then Apache Spark. All right, I hope this is clear. All right, now we'll go to streaming and real-time analytics. All right, so in this module, what we'll try to learn, we'll try to understand what is batch stream and batch and process stream processing, right? We have data in the form of batch and data in the form of stream. Okay, common elements of stream data solutions. All right, features and capabilities of Azure Stream Analytics and Synapse Data Explorer. So basically, Stream Analytics and Synapse Data Explorer are one and the same thing, only that Synapse Data Explorer is a more standalone thing than Synapse Analytics. Okay, we'll see that. So we have batch and stream processing. What is batch processing? In simple words, batch processing is collection of data in the form of batches and then storing it. Okay. Once the batch is formed and then you process it. So processing is not done as and when the data is received. On the other hand, stream processing, data is processed in a real time or near real time, right? Now, how do we trigger the processes? When should we decide when to process, or what should we do to make sure that data gets processed in batch processing, right? One is I can set the time. Okay, I want all the data to be collected within 1 hour and then process it. So the processor will wait for every 1 hour and then try processing the data. So whatever data comes in within that span of 1 hour gets processed, right? That is time triggering. Okay. Another would be number triggering. Okay, let's say I receive 100 data. Doesn't matter that data comes within 5 minutes or 10 minutes. But if you receive 100 data points, process it. Okay, that is triggering the process with the help of number, using the number of data. Okay, and third one is some custom processing, some custom triggering. Okay, the triggering method you define. Okay, how do we define? Let's say we are talking about this. If you see this example, there are cars. Okay, so if I define a process which will start processing when I have a specific car. So for example, let's say we have ambulance. Okay, once the type of car is identified as ambulance, you process data, right? So this is a custom trigger that we are doing by ourselves. Okay, so these are the various ways in which we trigger processing of batch data. Stream processing, we don't need triggering, right? Stream processing, it will happen every real time. So if that is happening, it will happen every minute chunks of data. The batches are real small here because we are instantly processing the data. All right. So what are the other differences? Latency, right? If I want to see the result, and if I set 1 hour as a time processing, I'll have to wait every hour to get the results on this data. In stream processing, I don't have to wait that much, right? There is absolutely very less latency. Okay, that is one thing. Then in batch processing, I have the capability to save data and decide what to do with that. In stream processing, it's not that, it is processing, right? I don't have the control whether or not to process the data or not, right? So each one has some of its advantages, some of its disadvantages. Can we have a system that clubs both? We can, right? So we can use both batch processing and real-time processing or stream processing and create a system with that. Okay, let's say I have a data. You select the data or have a batch of data, process it, and then if the results are really giving some insights, you work with it or you store it, right? Once the data is retrieved in certain interval of time, you can decide on what to do. So based on what processing we are using, batch processing or stream processing, we can decide on what to do. So there we can have combination of processes, right? Now let us talk about some systems or services that are provided by Azure. Okay, so Azure Stream Analysis. Azure Stream Analysis actually works with this structure if you see on the right. Okay, there will be input, there will be some query which will be performed by Stream Analytics jobs, and then there will be output. Okay, on the left hand side, what are the probable sources of input? Okay, it can be event hubs. If you see here, this is Azure Event Hubs. Okay, this is Azure IoT and this storage blob, right? So storage account. So the input to a stream analytics job is the service, right? So input or stream, the source of input for stream analytics jobs can be one of these three, or it can be many other, right? And it can be any other. Certain queries are happening on these jobs. Now, what is this query? What happens is the best way is to process these queries in the form of query string. Okay, now what is this query string? Query string is a piece of data that is to be analyzed. Okay, that is a raw data because we have not processed it yet. It is a raw data along with the method in which it should be processed. This is called as query. Okay, so we have data and then also defined the method on how it should be streamed. Okay, this is how we perform multiple queries on the continuous data that is coming to us. Okay, that is how Azure Stream Analytics job is being done. Okay, and then once the data is processed, data is stored into any of these outputs. Okay, it can be again stored back to Azure account. Okay, it can be stored as a relational database. Okay, as a SQL DB server, right? It can perform or it can become an input data for another pipeline. Therefore, we have Azure Synapse Analytics, right? Right. This data can be undergone certain functionality, or this data can be subjected to certain functionality, right? Therefore we have Azure function. Okay, event processed getting to another event, this is also possibility, right? So we have event hub as input, processing, and event hub as output. Okay, and if this data is processed at any point of time, I can analyze the data, I can have visualization, therefore Power BI, right? So these are the possible sinks. These are called as sinks, right? Sinks of data, where the data should go, and these are the probable sources of data. And what happens in between is actually perpetual query, right? Process data with a perpetual query. What is a perpetual query? As I said, it is a chunk of data along with a described method in which how it should process, right? Okay. Next is real-time log and telemetry analysis with Azure Data Explorer. So Azure Data Explorer is nothing but same thing is happening here. We have same sources of input, but here we are trying to optimize the data to give relational output, and for that we are doing the query with the help of a dedicated query language called as custom query language. So here in Stream Analytics, we did not define how the query is made. Okay, some select and okay, something is done, but here we are defining a specific special query language called as custom query language. Okay, and the syntax you can see here: log events, where project time. So what we are doing, we are taking the data, creating the event logs, okay, performing the custom query language, performing the query with the help of custom query language and get the results, right? Now this is done as a complete what we say standalone process. That is why we an Azure Data Explorer is a standalone service. Okay. So live data streaming also has an exercise that you can perform on. All right. Okay. Let us go to some knowledge check. Okay. Which definition of stream processing is correct? So we are talking about stream processing, right? Stream processing is where the data comes in continually. Okay. Collected in temporary store. No, right? Definitely, it is completely opposite. It is the batch. Okay. Which service would you use to continually capture data from IoT Hub, aggregate over temporal periods, and store results in Azure SQL databases? That is what we have been doing with Azure Stream Analytics, right? Yeah. Which language would you use to real-time log data in Azure Synapse Data Explorer? What have we done? KQL, right? Custom query language, right? Okay. Okay, I'll stop for a minute just to see if there are queries. Okay, what is telemetry analysis? Telemetry analysis is time-based, real-time based analysis. Analysis happening in the real time. Nothing, a synonym of real time. Okay, that's it. Okay, no other doubts. I don't see much doubts today. Not sure why. Okay, let me share back. I hope it's visible. Let us go to data visualization, the last part of this module, right? Data visualization is what we have been talking throughout, right? Data analytics is done, data visualization. Model is created, data visualization. What do we actually do? So this is we'll try to see, right? So what we'll see here, describe a high level process for creating reports solution for Microsoft Power BI with Microsoft Power BI. Yeah, so we'll be using Power BI to create very interactive reports, right? Describe core principles of analytical data modeling. I think we saw that. Identify common types of data visualization and their uses and create an interactive report. So yeah, so we'll try to do an exercise with Power BI desktop. All right, so what actually happens? So Power BI, the most comprehensive tool of Power BI is Power BI Desktop. I mean, this is designed as a standalone desktop application wherein you can, analyze, process. I mean, process, not processing actually, analyze all type of data, right? So every time we process the data, we saved it into any of these inputs, right? The input to Power BI Desktop is actually where the data, the process data was outputted, right? So it can be an Excel or CSV file. It can be again a storage file, SQL data server, Synapse Analytics, cloud or file. I mean, this is where all the process data comes. Okay. And then we define a model. What is actually defining a model? To provide what parameters should give me the result. Okay. Or what are the parameters that actually contribute to variation in result. All right. Parameter meaning dimension affecting measures. That is what you need to understand from model. Okay. So once I am able to create reports or create a visualization with the help of Power BI Desktop, I can publish my result so that others can have a view on it. Okay, others can have a look on it. Now, how will others have look? With the help of web browser. Okay, so this web browser allows us to have certain change of functionality. For example, if I create a report and if certain things are not according to what this user of web browser wants to see, he can manipulate that, right? Although it does not give that many extension with Power BI Desktop gives, but it is quite okay, right? Another would be to just have a look at the results and see the future trends, things like that we can use with Power BI phone app. Okay, so these are kind of a superficial use of Power BI, but Power BI desktop is more comprehensive tool for analyzing, right? So once the data or once the visualizations or reports or dashboards that you have created get published to Power BI service, it can be then later used by any we have given access to, right? The web browser person or the Power BI app. So this is what actually we will try to do with this data visualization tool. Now this is data analytical model. So you do see a star structure, right? Now here you will understand what I was talking about when I said fact table. Okay, in customer table, product table, and time table, you will see all sorts of data. It can be a string, integer, and everything else. But in fact table, you will only see numbers along with the timestamp. Okay, because it becomes very easy to understand timestamp, right? I cannot have an ID for a timestamp, right? So therefore, I have time key. Okay, anything else I can have an ID, right? So this fact table, if you see, it is all numbers, and if you actually want to read out a particular record from fact table, I can say a person with product key, customer key 1, right, bought a product with product key 1, okay, in number of quantity 1, generated a revenue of 2.99 at 1122, right, 2022. This is what I can completely write this record in the form of statement. All right. Now I just have to replace this product key 1 with the actual name, customer key 1 with the actual name, and things like that. That is why we call this at fact table, and that is why it lies at the center. Now, if we can have multiple branches, we see that it forms a star. Okay. Now, if I create customer with customer type, customer region, product with product category, all right, the age in which project should be used, okay, time with months, within a week, within a period, right? If that can be done, I am creating hierarchy of the star, creating branches of each branch of the star, thus giving it a look of not a tree but a snowflake, right? Because it is, you can compare it later. This is how data modeling is done, right? From this thing, we create a model. So if you see here, this cube acts as a Cartesian plane where you have 3 dimensions: time, customer, and products. And this is actually the measure. Okay, see this. What is the measure? What is the result? Revenue. Right? If you see this, they are underlined as measures. So the revenue, what is generated, is what I want to optimize, right? And for that, I'll change my dimensions, right? So product is a dimension, customer is a dimension, time is a dimension. All these dimensions contribute and form measures, right? That is why we represent a model with the form with the cube. Okay, here there are 3, so cube would be a perfect example to represent it. But if I had multiple dimensions, cube would not have been the perfect example because we cannot have dimensions more than 3 in physical world. But here it is just a representation of what is actually happening. Okay. All right, aggregate measures. Now these are common visualization report. Okay, we create reports in the form of tables and text, the most basic form, right? Then we create bar or column charts to have regional understanding, category wise understanding. Okay, line charts are done to analyze a particular parameter, particular measure, that is revenue, over time. So the x-axis would always be a time. It can be any time frame. It can be time in hours, months, days, years, but it will always be a time thing. Okay. Pie chart is to compare the product individually with the total number of products. Let's say. So we're talking about product as category. We can compare a category with the total categories. Right. So if you see here, category tools, hardware consists of 33% of those tools or the complete category. So it is to, this gives you an idea of what chart to use when. What chart would give better understanding of results when you have this particular as parameters, particular thing as a parameter. So let's say if I want to see the trend of a revenue over time, I'll definitely use line chart. Okay, if I want to see something category wise, I'll definitely use bar chart. If I want to see contribution of one thing as a whole of other parameters, I'll definitely use pie. Okay, now what is this scatter plot? Scatter plot is used to compare two things. Okay, so here you won't find time. you'll find another value. So revenue is still there, but there is marketing. So how is marketing affecting the revenue? And this will help you to actually create the model, right? So it is like creating function y is equals to f of x, okay, where x is the x-axis and whatever you see on the y-axis is the y revenue, right? So it helps you to relate two different quantities, okay. And then map is, as it is pretty intuitive, right? Map gives you the output or the measure area wise. In our case, the measure is revenue. So we are trying to see what the revenue is area wise, and the size of this circle actually gives the idea of whether the revenue is large or small or moderate, something like that. Okay, so this is how we will see different visualization reports. All right. I mean, we'll perform an exercise on this. So basically what I'll try to do is, with the time frame we have, I'll try to perform exercise on Power BI. Okay, I'm sure some of you have already done it and may have found it very useful and interactive, but we'll try to see, trying to do that. Okay, which tool should you use to import data from multiple data sources and create a report? Definitely Power BI desktop, right? Because phone app is not very comprehensive. It won't allow you to do that much. Okay, what should you define in your data model to enable drill down process or drill up and drill down analysis? A hierarchy, right? So I did not mention what is drill down and drill up. Probably I'll do it when we do the exercise. Okay, what kind of visualization should you use to analyze pass rates for multiple exam over a time? So when we do anything over time, what should we use? A line chart, right? When my x-axis is fixed with time, I'll use a line chart. All right, so I mean, these are the further learnings which will have information on every module that we have covered, right? Core data concepts, relational data, non-relational data, and data analytics, right? So at this point, I'm done with the slides, and we will take some questions. No questions? Okay, if you cannot unmute yourself, you can post your question on chat. Wait. Okay, wait. There is one question. At which stage and how data visualization happens? So data visualization is happens as soon as we have data in the data analytical store, right? Because data visualization is something that can be done when you have some filtered data. Filtering of data happens at data ingestion only, right? Once the data ingestion is done, then the data is stored based on what type of data it is in the data warehouse or data lake, or maybe in hybrid. So once the data is completely restructured, it is filtered according to your will, then you can have the value, what we say, visualization, right? Okay, I have completely misread the question. It is data validation. All right. So data validation happens when you, so like, let's say I have a file storage. Okay, I have a file storage. Now in file storage, I never made, in file storage, I never defined what type of data I wanted, right? File storage can have a blob, it can have file structure, it can have anything, right? But when I upgrade my file storage account to data lake gen 2 account, what I'm trying to do, I'm trying to have hierarchical structure. Okay, when I try to have hierarchical structure, I want to make sure that same type of data go in same type of folder. Okay, let's say if I create a folder for sales, I should have all the data that supports sales should go in sales folder, right? Now, if that is there to happen, whenever I try to put a new resource as a data, okay, let's say I put a data on customer, a file on customer, okay, is it necessary to, I mean, it is not necessary to see whether this data is supporting sales or is it related to customer before adding it, right? So this is the stage where you do validation. At the stage where you have set certain parameters that I want data from here, I want data from here. And then when the actual data is coming, you have to actually check the data, what type of data it is. So this checking is validation. right? So once you upgrade your account to data lake Gen 2, you have more discrete account, that is more hierarchical and more defined account. Now that account is defined, so to have proper filtering, you should have validation. I hope I cleared. Okay, I'll move next. Okay, so basically when you you have done the lab assignment, but you're not sure where this will be relevant. Okay, I'll give you a use case. So for example, if you are if you have created you're done with the assignments, every time when you create a resource, you must be saying that resource is getting deployed, this is getting deployed, database getting deployed. So deployment is happening, right? Everything is happening at the end stage. What was their deployment? So you're talking about applications. We're talking about web application, mobile application, embedded application. So whenever you are in a stage where you feel like I want to create application, you will be working with data. At any point you're working with data, and you want a platform or you want an infrastructure where you can work with this data, where all the processes are there to right from ingesting the data all the way till visualizing the data or using the data for your own application. You will be using these services. So one of the very good example would be when you are into creating applications. Okay, you will work with data. Okay, custom query language, there is nothing more to work on it. There is, see, custom query language is actually a form of SQL where it has its own syntax. Okay, that with the help of that syntax, that query language, we perform query on the input data, process it, and then get the result. That's all. Key differences between Tableau and Power BI, I'm not very sure. I understand. I mean, I've very recently started to work with Power BI, so should be able to talk about Power BI at this stage, not Tableau. Is the programming languages Python and Java can be implemented in cloud computing? Implemented in what? Right? So there can be multiple stages where you want to implement. You want to create a cloud service using Python and Java, yes, you can. You want to create an application that is working on Python and Java and then use cloud service to deploy it, yes, you can. So it depends on what is the activity you're trying to do with these languages. Okay, two platform of same genre. Is it the answer to Tableau and Power BI? Maybe, I'm not sure. Do you query on fact table if you want to select another column related to product key? Example, to select category of product table or customer key. Wait, let me try to understand. Do you query on a fact table if you want to select another column related to product key? Example, to select from category. Directly query the table, no? I mean, if I want to dig deep into a particular dimension, query the dimension, right? I mean, okay, till when can we practice lab assignment? Your deadline should be there along with the lab assignment, right? So whatever key you get, based on that, there will be deadline. Till that time you can do, I guess. Okay then, are we done with questions? Okay, so if we are done with question, okay, sir, what about student verification Microsoft platform? It is more of an operational query, and I'll try to get back to you on Teams. Okay, I'm not sure if so we wanted to have meeting with the Microsoft team, and we'll see how it can be sorted. Okay. Okay, so with this, I will move forward to some labs in PD 900. TP 900, you mean? Okay, we'll see. Okay, sorry for the background noise. Yeah, this is the last class. Yeah. Can you see the lab, your lab environment is being built thing, right? Is it being shared, right? Okay. Okay, so here we are in the virtual machine that is acting as a different computer, right? So it is a computer and cloud, and we will try to do Power BI thing. Okay. Now the problem with with that is we have to install Power BI within this system, right? Not the original system that I'm working with, but the virtual machine. Okay, so might take some time, and we'll see. Okay, so let me join in as student first. So if you see this interesting feature here, if you click on T, it will type it for you. Okay, so you can see the virtual machine here, right? It is using Windows 11 while my system is using Windows 10. Anyway, so I'll move to Power BI, explore fundamentals of Power BI with visualization, right? So first thing is to actually download Power BI. What I'll try to do is copy and open it in the browser given in the virtual machine. Full stop. If I do this, it will start installing Power BI. 455 MB, we'll have to wait for a couple of minutes. Meanwhile, if there are any doubts, I'll take. Uh, See, so we are trying to have this workshop just to give you an idea. See, some of you are actually working in the industry, so you have quite an idea of how to work with cloud services and what are the features that they provide, right? But some of you are like students, right, from engineering, second year, third year, who have a very brief understanding of, or at least, I mean, absolutely no understanding of what these services are. So we are trying to have this workshop just as to, give a clarity on what are the things that are there, what things can be explored. And that is the reason we haven't gone into much details of everything. We have touched upon things so that you get the understanding, basics, right? Overview. So that is the reason we are having these workshops. Yeah, that is okay, Tanish. If you are able to do, I mean, store the file at least for once, that is okay. Okay. I mean, see, the file storage is done only to make sure that, to give you an idea of how, this is how file storages are done. Okay. But the basic idea should be to be able to create a resource and then to be able to upgrade it. That is requirement. Okay. If you're not able to upload a file for some reason, it is okay, because there can be some stored things in the browser that might happen. So don't worry about it. Okay. Or there is other thing that you can do is just create a random file .json having some random data, not the one that the guide suggests. You can create your own and then try to see upload and see if it shows. We have three different storages: hot, soft, and when we talk about share, we discuss about disk type SSD, SSD. Okay, is there any dependency between them? Okay, yeah, so I think I got your question. So we're talking, so when we store a blob, there is this tier of hot, cold, and archive. And uh, when we have this file storage, we have the premium and standard. So this is file sharing, right? File sharing, I mean, the moment you go into file sharing, you are asking your fellow workers or employees to have the access to these files. Okay. Now, SSD and SDD, meaning the latency. I mean, see, they are not related, because here we are talking about storage, and as storage meaning to what store it is done. I mean, whether it is available readily, or whether it will take some time, or whether it will take some hours, right? And SDD and SDD is again it talks about latency, but about sharing. Okay. So dependency meaning, if we try to write out the process how it is happening, okay, then we can find out that relation. For example, if I have stored a blob with hot storage, and I've shared the same blob using file shares, okay, and I'm using a network called file system, network file system, NFS, right? Then I'm using in SSD. So I'm using a blob that is stored on SSD and in cold process. So yeah, definitely it will, you know, help in getting the results very fast, because now I'm using SSD to store and it is already there in the hot storage. So yeah, we can create that dependency. So it depends on, what is the actual path in which the file is retrieved. Yeah, you can definitely pursue advanced path after student verification. Yeah. Yeah, so see, the things discussed in this workshop are a kind of overview, right? So the slides that we'll be sharing will give you an idea of what things are there, but the actual course, if you go through the content, uh, is what I've tried to speak, right? I mean, there were things on slide, but there are things that I've spoken more, right? So that is the thing that would come with the course, right? So if you go through the course, that should be, and along with the practice exam, that should help you to, get the better idea for actual exams. Okay, slides will only give you idea. I will not help you to, greater extent. But yeah, it will be a good pointers to, how to proceed with the learning path. Okay, let me check if this is downloaded. Okay, so it is downloaded. I'll share again. There you go. Right, so our Power BI is downloaded. We'll open the file to install it. Will take some time, okay? Meanwhile, let me see what we have got in the system. Or they would come in downloads. Yep, it started. Right. Remember, this installation is happening on the VM, not in my machine. Okay? So we see two setups. We'll cancel this one. Yeah, so we know that one setup is still going on. Installation should take a couple of minutes more. Okay, what should we do to secure a cloud server VM other than the you see what happens is the moment you set up VM, the thing that we haven't done is here is to log in, right? So you will be only able to create a VM in Azure subscription only if you are logged in, right? So once you're logged in, then your account is only available to you. I mean so this is the advantage of a platform as a service or infrastructure as a service, right? They will provide you they will provide you only very few administrative rights, right? Things like security and all are taken care of. Yeah, today's slides are not yet shared. We'll be sharing after the session. Currently, we do not have a chart, something like that, but yeah, we can try to at least add all the services that we have introduced here and relate them as to how things are, how you want to go with things, right? So if you are looking for an application that requires SQL database server, then you need a VM and then deployment. So all these things we can try to give you things that we have, services that we have introduced in this set of lectures. We will try to give a a mind map of that. Yeah, it is. So we will try to do that. I mean, therefore. Okay, so we got our Power BI installed. We'll quickly move to it. Let me share the screen. Okay, you have another MLT session, right? Okay, anyway, those who have MLT session can leave. This session will be available on YouTube also, right? So you can later watch it. And just as a piece of this workshop, I'll still complete the exercise. All right, so I think you can see the screen. All right, well, let's finish and then let's close this also and let's minimize the browser. and we will be opening Power BI now. I'm not sure if it is launching by itself. Let us launch it. Yeah. Basically, what I'll be doing is, if you can see the guide here on the right, I'll be strictly following it. Okay, and then finally we should be able to see visualization something like this. Okay, that is the aim, and we'll finally save it because this is a desktop application, so we can save these as local files. Okay. All right, so the very first step is to get data. Okay, so our resource would be web, so we will be connecting to web. Where is web? Yeah, here it is. Okay, then we'll connect to web. Right, so from web we will be putting in this URL. Okay, very good way is to just have a cursor here. Have a cursor here and just click on this T, so it will write that URL for you. Yeah. Right. So you can see that the data has been brought to the system. Now we need to load it. Okay, so it is loaded. Okay, now how to check if it is loaded? It will come in fields on the right. Okay, yeah, it is prompting me to sign in, but I won't do that. But okay, let's see. Once it is loaded, it will come in the fields. Right? Yeah, so it is a bit unresponsive for now. I mean, it is lagging a bit, but that is okay. Right, so you see customers here. So what we have done is we have loaded a customer.csv table. Okay, similarly we'll be doing for orders and probably other thing, we'll see. Okay, the next thing would be to do it for products, and the other thing would be to do it for orders. Same thing we'll do. We'll from here get data. Yeah, data. Then our source was web, right? Basic web. Here I will click on T so that it puts in the URL for me, and then I'll again load it. Okay, loaded. Yeah, one quick thing here. If you click on the link which downloaded Power BI for you, what will happen? It will download, if you directly click on it, right, it will download Power BI in your own system, not the virtual machine, right? Now, if you run Power BI with your system and try to load this link, you might face problems because there are some authentication issues. Why are we doing this? Because we created Power Desktop here, and the virtual machine that we have created was actually linked with the Azure account. Okay, that will not be the case with our system. Okay, so if I try to go to a link and there is an authentication error, there you might face problems in loading file if you run Power BI in your own machine. Okay, so the better idea would be to copy that link in a browser opened in virtual machine, right? This is one thing that you need to take care of. Okay, similarly, the last loading thing we'll do with I guess orders.csv. All right, so we see that there are three tables added. Now these tables are actually entity tables, right? From the entity tables, we'll be creating a model. So if we go to model, we'll see that there are three tables connected to each other. Okay, I'll just arrange it. customer, products, orders. Okay, so I've arranged them. Let us create some hierarchy and other stuff. Okay, so this is the model and this is where I see. What it says now, in the order table, select revenue field and then in the property pane, set its formats to currency. Okay, so we have order, we have revenue. Let me right click. Okay, probably so what it says in the orders table, select the revenue field. Okay, go to revenue field. Okay, what next? In the property pane, set its format to currency. So if you see here, this is the property pane. I have minimized it. So what we need to do, we have to set its data type, set its format to be a currency. Okay. Revenue is okay. That is okay. Yeah, format is general, so I have to set it to currency. Okay, why we are doing that? Because then we'll have actual currency values, and then it will be coming as a actual currency values, not just a number whose row name is currency. It's not like that. Okay, so this is set. Next, in the product table, right click on the category field or click on these three dots and select create hierarchy. So where we have to do that? In the category table. Order summary, order item, customer item. Where is it? Okay, product table. We have category, so we have to click on these three dots and create hierarchy. Okay, this steps create a hierarchy named category hierarchy. There you go, right? You need to expand and scroll in the product table. So this is what it means. You can scroll and see that, okay, category hierarchy is created, and this is, we have added category to that hierarchy. All right. Next is in the products table, right click on product name field. This is the product table. So to right click on product name field, and we have to add it to hierarchy. Which one? Category hierarchy that we have created. Okay, in the fields pane, right click on category hierarchy, and we will rename it to categorize products. Categorize product. Okay, now on the left side edge, select data tab, and then in the fields pane, select customers table. So this is where we are talking about. This is report, this is data, right? Then we will go to customer. Customer, there is city. Let us select this. Okay, and what next? Set its data category property to city. So here you see data category, right? This has to be set to city. Now, why is this useful? It says that, right? This step will ensure that the value in this column are interpreted as city names. Okay, and this will be helpful in creating map visualizations. Okay, if you don't set that, van news or branch or Modesto is only a string. Okay, now let us try to create some report. Okay, now on the file menu in options and settings, we'll select options. This is file, options and settings, select options. Okay, let us see what it says more. Then we have to go into security. There you go. Use map and field visuals. That has to be enabled. This one, right? And then we have to select on OK. On the left side edge, select the report tab and view the report design interface. Okay, we'll go to report. Right. Okay, in the ribbon above the report design surface, select a text box and add text box containing sales report. So we will create a text box. Here it is. Right, we'll click it here and what is it, sales report. Okay, sales report. Some some information on the formatting also. Format the text and make it bold with the font size of 32. Font, okay, nothing to change with this thing. I'll make it bold and the size has to be set to 32. That's all, right? Now select any empty area. We did that on the report to deselect text box. Then in the fields pane, expand products and select the categorize product field. This is the field pane. We will select categorize product field. So we'll see that a table will be coming up. This step adds a table to the report. Okay, we'll move it. We will first shorten this a bit so that we can move it above. Okay, and we will slightly maximize it. Okay, that's all. Okay, with the tables still selected, table is selected. In the fields pane, expand orders and select revenue. So you have to expand orders and then select revenue. All right. A revenue column is added to the table. You may need to expand the size to see it, right? So we see that revenue is created, right? And now why it got this sign of dollar? Because we set it as currency, right? Now the revenue is formatted as currency as you specified in the model, right? And then there are things like decimal point that we didn't satisfy. Hence we have 928.9, something like that. That can be done later. Okay, now we'll go back to the model or data tab and change the decimal places if you wish. We can do that later, okay? With the table selected, table is still selected. In the visualization pane, select stacked column chart. This is my visualization pane. Okay. Table, sorry, yeah, table is still selected. This is the format, right? This is where you have to go. Stacked column chart. Right, so we see stacked column. I mean something like something which it is expecting us to see is something that we are seeing here, right? This is stacked column chart visualization. The table is changed to a column chart, right? Now, above the selected column chart, select bottom arrow. Okay. So what is this bottom arrow? Actually, this is called as a drill down. Okay. So if now you remember while creating a table, we also created hierarchy, right? So if I click on drill down, I am asking or I am allowing my table or my visualization to go back into each subset. Okay, for example, if I have products, what was the hierarchy? Let's say I created category of products, right? That's why we have categorized products, right? Then within the category of products, I again created a category, let's say products according to age, right? Products according to gender. So if I do that, I am trying to go in one step below, right? In the folder structure or in the structure, I'm going one step below. That is called as drilling down. Okay, if you see here, you keep on moving to in the diagonally like this, right? If you have more categories and more categories, this diagonal movement is called as drilling downwards, right? If I go back to a superset of my current working, if I'm in categorized products, from there I go to products. Okay, if I'm going upward, it is called as drill up. Okay, now if this is done, I can just click on any one of it and see the individual reports of that, right? So I clicked on anyone, I don't know which area. Okay, I clicked on road bikes. Okay, and then within road bikes, I saw that okay, these are the various bikes and these are the revenue from those bikes. So what I've done, I've categorized that road bikes into the name of bikes and then revenue according to those names, right? So this is drilling down. Initially, I had a superset of road bikes. Now, along with superset of road bikes, I also have the name of bikes and revenue created by each bike, right? That is called as drilling down. Similarly, we have drill up. So if I click on this, I will come back to that same position, right? And now if I click back on this button, I will deactivate drilling down process. So clicking on this will not actually go back to that categorized results, right? It just highlighted me. That is the idea of drill down. Okay, let us select a blank area. Let us move ahead. Okay, in the fields pane, select quantity. There you go, quantity. In the select quantity in the field, quantity field, and in the orders table, there is an orders table. Okay, and the category field in product table. Okay, we're creating category field in product table. So what is this? Now we are creating total quantity based on the category, right? So we are creating currently it is a bar graph, but we are creating total quantity of sale based on the category. So we have selected those two and then it created. Okay, but if if I'm trying to sum up the quantity according to all the categories, if I'm trying to compare sum with all the categories that are there, what is the most relevant graph? A pie chart, right? So we'll convert this chart into a pie chart. Okay, so this is the visualization pane and I will click on pie chart. So now I get all the categories and their share, and share in the sum actually. It is showing 0% because probably it is, wait. Yeah, now the numbers have come up. So it takes time because it is quite heavy. Right, so this is a better option. Why? Because now I get all the categories and their share in the quantity. Next, we'll go to blank area. Select a blank area of the report and then in the fields pane select city. Customers table as city. Okay, and see if I as soon as I clicked on city, it created a map visualization for me, right? Now this map visualization only produce city. Now what should I want? What do I want to see within the city? That will be city, and then what I want to see is actually revenue. Yeah, so we will see revenue city wise. Okay, I can just scroll it. The complete figure I can scroll here. Let me minimize a bit. Okay, now if you see, I can move this map completely within. Okay, I can scroll in so that I can zoom in, scroll out so that I zoom out. Right, so I see city wise, and if you see there is differences in these circles. Why? Because the revenue is different, and the larger the radius of circle, larger is the revenue, because that is the quantity that we are looking city wise, right? So that is what I have shown now. So basically this gives me a very good report on revenue by category. Why? Because this is creating a bar chart. Again, quantity by category, right? Because I wanted to have the complete contribution of one category in total sum, right? And then I wanted to see revenue by city. So very good visualization is being offered with the help of Power BI, right? Now, since it is a desktop application, I can very well go and save it. Okay, and if you see, the Power BI application are saved as PBIX. Okay, so I can just name it anything according to my will, sales, and save it. Okay, and then since I saved it, I can definitely use it. I can open it, open report, and I'll see sales.pbix. So it is a Power BI report. Okay, so that is what I wanted to give with this Power BI exercise, right? I'll stop sharing for a minute. Right, I hope that was intuitive. You can also go by yourself and do the exercise, and the only thing, I have followed the guide and only plotted those things that were given. You can plot anything you want, right? You can explore other charts. You can explore scatter plot just to see how one thing depends on other, right? You can see trends in time with the help of line graph, right? So ultimately it gives me a very wide range of operations. And why basically we are using Power BI? Why not Excel? Because Excel is not that comprehensive. it will hang when we have large amount of data, right? So here we are not talking about data where number of rows are, limited to 1,000. Here the number of rows can be in millions. Okay. All right. So that is what I wanted to give. Any issues, any queries? I guess operation queries were being handled by Piyush. Yeah, and there is a YouTube link pasted, so you can later go ahead. And this is definitely for this will definitely be helpful for those who had to leave for MLT sessions. All right, guys, tell me any doubt? Let us discuss. We are already past 11, so don't want to waste much of your time. There are no doubts. We'll drop the session, close the session, and I would collectively thank you all for attending and being here so patiently for the course, for both the course AZ 900 and DP 900. And I hope we at least give you a basics of what Azure Cloud Computing is. There are a lot of services that you can go ahead and explore. And the thing is, every service caters to certain business problem. So as long as you don't have a problem definition, it will be very tough to understand what actual service we want to use, right? So you can go ahead, find out a business problem, and then later look at a particular tool. All right, then I would thank you all for joining and officially close this session on behalf of IIT Madras. And we will try to have similar sessions. Okay, thank you everyone. Thanks for joining. If you have your MLT sessions, you can drop off.